Okay, Bismillahirrahmanirrahim. Okay, folks, welcome back to our full examination papers that we're doing. This is, I think, part 2 or part 3. You'll find out when you see the video clip number in YouTube. Now we're going to restart from where we left off. So let's take it forward to page 18. Okay, so we're on question number 18. Step up a bit for me, please. Right. It says the diagram shows part of a pattern made from tiles. This is paper 1. Okay. So paper 1 meaning non-calculator. Okay. It says here some part of the questions actually come off the bottom of the video. So we can take up just a few bits here. A little more. That's it. Stop there. Because the pattern is made from two types of tile. Tile A, tile B. Both tile A and tile B are regular polygons, and the key word in this question is the word regular, because the word regular means what, Samia? What does the word regular mean? Thank you, Samia. The word regular means all the sides are of equal length, so all the internal angles are also equal. Thank you, Samia, for that answer. Now, if we have got a regular three-sided shape, then that can only be one particular type of shape, which is the equilateral triangle. A regular triangle is a triangle that has got all lengths which are equal. So by them using the word regular, that has now directed our attention towards labeling and knowing that that triangle is none other than an equilateral triangle. An equilateral triangle has special properties. What do we know about an equilateral triangle? Each angle is equal to 60 degrees. Okay. Now what we're going to do, okay. What we're going to do now, we're going to look at one point here where everything joins together. In order for us to get a pattern working, everything has to join together without having any gaps. So what do we know? This angle here, the inside of tile A, because we can't see the rest of tile A, we don't know how many sides it's got. So we could just guess that it's got 8 or something, but we might be wrong. At the moment we are sure that tile B is an equilateral triangle. Each angle is 60. Tile A, the angle, the internal angle, each one, we have got no idea at the moment. So we're going to call it X. Okay, that's X. And that is also X as well. Because this angle here is this angle that we have here. I'm going to call that X, and that's X. Now we need to form an equation. Form an equation to do with the angles around a point to work out the value of X. So let's start. So we say X, this X add that X, add the 60, gives us the property now. So what is that? What do all the angles add around a point? 360. You can say a bit louder than that, Samir. Okay. 360 degrees. So let's work out the value of X. Let's simplify first. We have X add X, that gives us an answer of
X squared.
Well done, Samir. Okay, 2X plus 60. When you add X together, X with another X, we get 2X. You only get X squared when you multiply X by itself. It's a common mistake. Okay, 360 degrees. Now, we need to work out the value of X. We have 2X plus 60. And as I've shown you in the previous two-step solving simple equations, we need to start at the X. X is being doubled. Call this the first action, and then it's been added by 60, that is the second action. Okay, now in order to solve this equation, which action do we move first, Mia?
Second action. The
second action moves first. Opposite add 60 is?
Minus 60.
Minus 60. So now we have left with 2X is equal to 360 minus 60, which is?
300.
300. So this angle and this angle together makes 300. So now we say the opposite of time by 2.
Divided by 2.
So you have 300 divided by 2, that'll give you
150.
So now we know that the internal angle of the tile A is 150, one of them. We need to now work out what the external angle is. So for example, in the shape here, okay, an external angle is basically, if you continue the line of the shape, this angle here and the internal angle together gives you 180 degrees. Internal angle plus an external angle added to 180, that's property of the line here, the point. So we know that the external angle is equal to 150, add a number, gives you 180, which is
30 degrees.
Bit of mental maths, 30 degrees. So the external angle is 30 degrees. So we need to find out what shape, how many sides the shape has that has an external angle of 30 degrees. Now we have a rule. 360 degrees divided by the number of sides gives you the external angle. Okay, now, in this particular rule here, we know the external angle is 30. So if I rewrite that equation over here, if I got some more space, 360 divided by n is equal to 30. We're nearly there. We've got to work out the n. So this 30 degrees external angle corresponds to a side with n number of sides. Let's work out what that is. So how do we get the n from the bottom to the top? Samir, what do we do? Thank you, Samir, that's cross multiply, well done. The n goes up there and the 30 comes down here. Okay, opposite divide by n is time by n, and opposite time by 30 is divide by 30. Excellent answer there, Samir, well done, I'm really impressed. Okay, so now we have 360 degrees divided by 30 degrees, that gives you n. And if you do 360 divided by 30, first of all we divide by 10. 36 10 divided by 3 will give you an answer of 12 sides. Okay, the question says to work out the number of sides tile A has. Tile B, we know is 3. So tile A, which you just worked out now, is 12. So the answer to that question, and that you can't tell too easily from the diagram with half the tile shape missing. Okay, right. So maybe ready for the next question. Okay, that was question number 18. Let's move on to number 19, please. Right. There's a board of that. It's looking beautiful. Okay, right, question number 19. Okay, a little squirrel is leaving the room. Okay, Samina recorded the times, question number 19. In a minute, some girl took to do a jigsaw puzzle. Shortest time, lower quartile, median, upper quartile, longest time. This is all the information we need to do a box plot. Okay, a box plot. If I just do a quick sketch for you here. Okay, let's have a look at this. Let's close the door. Okay. The shortest time goes here. The lower quartile goes here. The median goes here. Upper quartile goes here. And the longest time goes there. So when we do a box plot, all of these numbers correspond to a particular part of the box plot. Here's the box and here's the whiskers. So the beginning of the box plot, which is the smallest possible time, shortest or smallest value. The end of the whiskers is the longest value, the longest time. The beginning of the box is the lower quartile. The end of the box is the upper quartile value. And the line that goes in the box is the median value. So this is like a little kind of like a rough diagram of where all these numbers should go when we start doing over here. Okay, right. I'm going to do this freehand at the moment. Please make sure when you copy this example, you use a ruler. Okay, where I can use ruler, I will use ruler. Right, it says shortest time is 18. So let's look at the scale. Now from 10 to 15, we have 10 little boxes. Mia? Yeah. 10 little boxes. We have 10 little boxes to represent 5. So you need to know that what is one of them worth. So if you go down to one little box, so 10 boxes worth 5 values. So each 2 boxes is worth 1. So if you want 18, you're going to go to 15 and go forward by 2, 4 and 6. My screen here is not too focused, but I hope that's about right. That should be there, that should be 18. Okay, alright, let's try to use a ruler. Okay, there's my starting time, so I've done that one. Okay, the lower quartile is 25. 25 is an exact number there on the scale. 25. That's the lower quartile. Done. Median is 29, so 29 is going to be from 32 squares back, because each 2 squares was 1, so that's going to be there. Okay, so we have here medians done. Next is upper quartile is 33. So 33, well this is going to be 30 here, as far as I can see from the projected image isn't as good as looking at the graph itself. So 25, yeah, that's 30. Okay, that's 30, 33. Remembering 2 squares is worth 1, so we're going to go forward by 6 squares. 31, and that's 1, 2, and 3. Okay. Oops. Okay. And the last one is the longest time, which is 44. So 44 is one number before 45, so you come back by 2 squares. It should be there. Whoops. Okay. Now, what we're going to do now, we're going to join them up to make the box. The box plot can be okay. Are we happy with that, Samia? Okay, Samia needs a ruler. Okay, we've got Samia. Ruler here. It's very important that you establish the scale. Don't assume that one little square is worth 1. As we can see here, we've gone across by 10 squares, but we've only gone up by 5 values. So it's very important to calibrate the scale, otherwise your numbers will be all over the place. Okay, so we've done that. So we record the times, so we've corresponded all these values to the correct position. I'll just quickly go over that once more. The shortest time is at the front. The lower quartile is the beginning of the box. The median is the line in the box. The upper quartile is the end of the box. And the longest time is the end of the whisker. Okay? So them are your 4 points. Okay, so I think what else is on the paper? I can't see the rest of the question. Okay, the question says now, the box plot below shows some information about the times in minutes some boys took to do the same jigsaw puzzle. Compare the distribution of the girls' time and the boys' time. Okay, well we're going to have some issues now. How do we get them both on there at the same time? Okay, it's okay, Lila, that's okay. That's fine as well. Smith, can you actually take this graph and take it above that graph? Just take it above. Get that one above it. So then we can have one above it. Okay, I'll make it back to the same size again. So no, here we go. Bring it close. What are you doing? I'll make it back to the same size so it's the same size as it was before. Up a bit. Up a bit. Oh, take it up a bit. Okay, right. Right. Bring it a bit closer. Bring that a bit closer. Okay, right. A bit more closer. A bit more closer. Let's just stop there. Okay. The way that the diagram is, we have the one that we drawn on top and this one on the bottom. For the sake of our issue they have here on the board, I'm going to have the bottom one on the top and the top one on the bottom. It doesn't really make any difference which one's on top, which one's on the bottom. But this is now to scale, everything the right size. Okay, we need to compare the data. The one that they're giving us is the one they're giving us now. That one is for boys, and the first one was for the girls. Okay, so this one here is the girls one, and this one is the boys one. I'm going to look off all the extra stuff on there. Right. Okay, so we need to make a comparison between the two graphs, between the two box plots. So one of the things that we can notice is that the boys' interquartile range is much bigger than the girls. We can see that the girls' median value is higher than the boys. So any of those two particular comments are something that we can write down over here. Compare the distribution of the girls' times and the boys' times. So let's write first of all, right, the boys have a larger interquartile range than the girls. So I check that the video, if you're not clipping the bottom of the video, okay, we're just about at the limit of the bottom. Okay. Alright, just making sure. That one is the boys one. Okay, not there. Right, what else can we say? What else can we say? Okay, we said that the girls' median value is higher than the boys. Okay, I'm going to run out of video space here with the camera drops off. So I'm going to write my second comment up here. So the girls is a median okay. So let's compare the distribution. So we made two comments, and that should hopefully give us our 2 marks. Okay, next question. Okay, let's go for the next question, please, Mia. Okay, we're going to have to break away soon in this video because it's coming up for time for Salat al-Maghrib, and we need to pray. I will come back in another video in the series. What time is that? Check on the net.